All attendees are in listen-only mode.
Hello, everyone, and welcome to today's webinar, UNH-IOL Ethernet Test Tools. My name is Mara Bernazani. I'm the Communications Coordinator at the UNH Interoperability Laboratory. Our speakers today will be Jeff Lepak, Enterprise Industry and Operations Strategic Manager, Kay Doobie, Operations Manager, and Stephen Johnson, Technical Manager of Ethernet Technologies. After this presentation, we will have a Q&A session. We encourage you to submit your questions at any time during the presentation by using the question box on your screen. We will collect these and address them during the Q&A session at the end of today's presentation. Just a little housekeeping before we get started. For those joining by phone, please mute your line, and please do not put the conference on hold. The hashtags for the webinar are hashtag Ethernet and hashtag Ethernet testing and hashtag 10gig. Today we'll start with a quick overview of the IOL as our Ethernet's testing background, and then move into the commercial availability of our new testing tools, Bitfire and Bitfire 10G. Okay, let's get started. I would like to now turn the time over to Jeff.
Good morning, everybody. And first, I'd like to thank everybody for joining this webinar about our commercially available Ethernet test tools, which we're very excited about. But what I'd like to do to start is just give a little bit of background on the University of Hampshire Interoperability Lab about who we are and what we do. So the UNH-IOL is a globally recognized independent test lab for the networking and data communications industry. We have a huge breadth of technologies that we test in that space, over 30 different technologies, all under one roof. So it's a very unique environment. We were founded in 1988 and we're located at the University of New Hampshire in Durham. And as part of UNH, we also train, educate, and employ students for future careers in the data communications space. So we have a two-part mission. We are a nonprofit organization. We are 100% funded by commercial industry with over 150 different unique member companies. Those member companies constitute over 250 memberships in those 30 different technology spaces that we test in. And our membership model allows companies to fund just the technologies they're interested in. We're located in a new facility as of January of this year. It's a 28,000 square foot space. It's about an hour outside of Boston, so it's very convenient for those located on the East Coast. But like I said, we're a globally recognized company, so we're happy to interoperate with everybody across the globe. So that's a little bit of background on who we are, and now I'd like to jump into what we do here. What we do is we enable multi-vendor interoperability. We also provide conformance testing and develop custom testing solutions. So what do I mean by multi-vendor interoperability? I mean bringing products from different companies together to ensure that they work well, work as users would like to see them work, which helps not only those companies bringing those products to market, but also enhances the marketplace by making that technology recognized as something that's high quality and easy to use. On the conformance side, we also provide conformance testing against standards, so to ensure that you are implementing something the way it's designed to be implemented. And we provide certification for logo programs as well for technology spaces that have such programs. And all of these are different testing services that we offer to companies on a confidential one-to-one basis. We also have a lot of industry involvement. We attend industry forums and standards bodies to give direct feedback on the standards that we're working with, often very early in the implementation to ensure not only those standards are robust, but that they're testable. So that's something unique that we provide as a test lab. We also promote early adoption of technology through collaborative group testing at Plugfests. We have a 4,000 square foot pre-wired space that's dedicated to bringing multiple companies together under one roof at one time to help kickstart a technology. In addition, in those 30 different technology groups, we have world-class test beds. So thousands of devices across our laboratory, which our member companies can come use and gain access to make sure that they work with all these other products that are available in the marketplace. For Ethernet testing specifically, we've been testing Ethernet for over 25 years. We have extremely large test beds in this space, hundreds of available link partners on everything from 10 base T all the way up through 100 gigabit Ethernet and soon to be 400 gigabit Ethernet. We provide conformance testing from the electrical or optical layers through the PCS right up through MAC and flow control. We provide testing services for power over Ethernet devices, so devices that either source or receive their power over the same data communications wire that the actual data communications are happening over. And we have a nice membership model to help collaborate with industry, which allows customers to come join for an annual period at one flat fee and gain testing throughout an entire course of a year. We make extensive use of our in-house test tools to drive down to the single bit level of Ethernet devices. These test tools are developed by UNH-IOL staff and students. They're specific to the job at hand, either controlling scopes remotely, interfacing with commercial tools, and/or custom HDL, which is what the rest of this presentation today will be about, is a couple of those solutions. And the exciting thing here is that the commercial availability brings our expertise directly into your lab so that you can do a couple different things on the app and application level. I'm going to hand it over to my colleague Kay Doobie right now, who will talk a little bit more about those apps and applications.
Thanks, Jeff. As Jeff mentioned, we've developed several proprietary test tools that help us run our testing. One of them, Bitfire, is a tool that we've used for years in-house. We used to call it UFET, or the Universal FPGA Ethernet Test Tool, but this is now being made available to our customers, and so we gave it a much nicer name. One of the services that we provide to our members is the testing aspect. We provide our results in an industry-recognized report. These reports can then be used as part of your marketing materials for sales applications, as part of your quality control process, or even as feedback to your engineering team during that development process. By having some of our test tools on site, this allows you to perform some of our testing in-house, either for times when you don't need our official report, or maybe you're just checking a specific behavior, or even as part of that process to prepare the device to send to us for official testing. Pre-testing a device before sending it to us for that testing allows us to provide more accurate testing in a more efficient manner. It can help to cut down on that setup process, as well as to eliminate unnecessary debug time, as you know that the product will work with our test tools before it comes to our facility. By having a Bitfire in-house, this allows you to also replicate our test setup. So if we do find something unexpected or possibly non-conformant during the testing, we're able to walk you through the steps that we did to find the issue, and then hopefully you're able to find a solution using your own team at your facility. Having our test tools available to you will also let you do some regression testing as you make updates to your devices and make new revisions down the line. Now, our Bitfire is not designed to traditional packet generators, but more as a complementary tool to help enhance the testing that you can perform in your own labs. All of these features combine together to help you decrease the amount of time it takes to get your device up and ready for market. In order to perform our testing, we have developed a rather broad range of test scripts to go along with the test suites that we offer. Our scripts are designed to test conformance to 4 different sections of the IEEE 802.3 standards, which covers your general Ethernet technologies. We have scripts available for Clause 4 MAC testing for 10 base T devices all the way up through 10 gigabit devices, at least for our Bitfire systems. These scripts test the functions of that media access control sublayer, including your errors, collisions, and preemption, which is a new functionality that we've added, and the preemption is used during the prioritization of different frame types in the audio-visual bridging space. So it goes a little outside of our traditional Ethernet space, but it's still something that we can do in our MAC testing. We can also test the pause behaviors for your Clause 31 flow control testing, allowing you to check the timing and the responses to traffic when pause frames are received. For our 10 gig bitfire, we also have clause 4 RS, or the reconciliation sublayer, which is a 10 gig technology for the detection and transmission of faults on a connection. And then we also have test scripts available for 3 different PCS clauses, including 3 different types of block encoding. So we have the 4B5B, which is your clause 24 or your fast Ethernet, your 8B10B, which is a clause 36, so your gigabit Ethernet, and then the 64B, 66B, which is your clause 49 or the 10 gig PCS. The bitfire software will allow you to run each test manually, or in some cases we can actually run the whole test suite automatically. The software also includes several different output options, which vary from bit-by-bit views of a frame that hasn't been broken out, all the way up to more user-friendly views. But it won't output one of our reports. You still have to come to us for that. And now I'll pass you off to Steve to talk more about our bitfire system.
Thanks, Kay. So as Kay said, we're very happy to announce the commercial release of the bitfire test tool, which is a tool we've been using in-house for many years, and now you'll be able to use it in your own lab. So I'm going to talk a little bit about the hardware and software of the bitfire family of test tools. So the bitfire is based on the Kintex 7 evaluation platform, which is a versatile piece of hardware made by Xilinx. The bitfire comes preloaded with custom HDL code, so there's no programming or setup required. It supports both fiber and copper media in the form of an SFP plus cage and an RJ45 jack, and it also has a USB UART port for easy interface with our software. The software interface for the bitfire tool is a Visual Basic based program, which is built for Windows 7 and Windows 10. So when you first open the software, you're going to see this menu. This is the main menu for our software interface. This is where you can configure the hardware, designate standard MAC and IP addresses for automated testing, and select the speed you want to test at, as well as the media type. I want to talk a little bit about the speed selection, because this is how we will be licensing this test tool. You'll have the option to license this tool based on the Ethernet memberships that you have at the IOL. For instance, if you have a fast and gigabit Ethernet membership, you will be able to license the tool for those speeds, but not 10 gig. Now I'd like to talk a little bit about the test station interface. The test station interface is really the main event here. This window is broken up into 3 sections, and I will talk a little bit about each. The 3 sections are the frame generation menu on the left side of the screen, the upload window in the top right side of the screen, and the capture window in the bottom right. The first part I'm going to talk about is the frame generation menu. This menu allows you to easily generate many different frame types for a wide range of testing. At the top of the screen, you can see the sequence generation template. This allows you to generate different streams, be it a single test frame or a test frame wrapped by valid frames before and after. This can be useful to ensure that the reception of your test frame isn't affecting other valid frames. Below that, we can see the frame configuration section. There are many different options here. We support a number of different frame types, including ARPs, ICMP, pause frames, PoE TLV frames, and M-packet preemptible frames. Aside from the frame type, we can also configure the size, as well as add VLAN tags or generate snap frames. If you're testing flow control functions, you can specify the pause time. And if you're testing gigabit half duplex, you can generate frames with any amount of extension that you would like. At the bottom of the screen here, you can see the hardware control buttons, which let you easily upload, transmit, capture, and download sequences. This tool also has some useful triggering capability, and this trigger The triggering on the Bitfire system allows you to create a trigger individual bit patterns as opposed to the reception of an entire frame. So for instance, if you're testing Mac functionality and you want to cause a collision during the preamble of a frame, you can configure the Bitfire to transmit a frame as soon as it receives the preamble of an incoming frame. This triggering capability allows for very in-depth PCS, Mac, and flow control testing. The next part I'd like to talk about is the upload window. There's not too much to say about this section, but essentially after you generate your streams over in the frame generation window, they will appear here in the upload window. This then allows you to double check your streams for errors before you upload them to the Bitfire, which can be very useful when you're generating long test streams. The last section of the software I'd like to talk about is the capture window. When you click the download button over in the hardware control menu, your capture will appear here. So there are two parts to this. At the top of the screen, we have the frame parser, and then below that, we have the actual capture. So using the parser menu, you can select which frame parser you'd like to use. The one that's currently being displayed is the frame detail parser, and what this does is break out the header information of each frame for easy digestion. We also have a few other options like a simple frame parser that just displays each frame without breaking out any of the header information, as well as a raw MII format that will display the capture as if you were probing the MII pins of your device. As far as the actual capture goes, you can see that the window is color-coded to highlight errors, such as CRC or alignment errors. And another useful feature here is the sequence number, which is located in this capture between the size and the preamble fields. So when you're generating frames, you can assign a unique sequence number to a specific test frame, which makes it much easier to pick out in a long capture. So now that we've heard a little bit about the Bitfire system, we will hear from Jeff Lepak again about the Bitfire 10G.
Thanks, Steve. The Bitfire 10G is an enhancement of a very similar system, operates using the same concepts of control and GUI interface, only it's specifically designed for 10G base R5. So again, this is something we're very excited to bring into your own facilities to help speed up some of the testing you do. The scripting is slightly different than for the gigabit and fast Ethernet speeds, as it's done at the XGMII or 64x66-bit block level. And what that is for is really to enable the flexibility necessary to do really thorough testing at the clause 49 layer, where you have to be very specific about the bit ordering inside those 66-bit blocks. It allows for triggering on many different block types, and again, this is similar to the Bitfire for lower speeds, but it's specifically analyzing block encoding types. So it allows triggering for things like not idle. It also allows triggering on any control code type blocks, which is extremely useful for the viewing of fault control handling, things like local fault and remote fault. And it also has triggering available for start of frame blocks, as those can happen in either the 4-byte or the 0-byte position. So it's a really flexible triggering tool to allow you to analyze what's happening at that PCS layer. The capture length exceeds 512 blocks and allows you to trigger to see both things happening right before that trigger event as well as after for a complete debug of the test frame under analysis. It also allows you to analyze at both the single bit level, so you can dial right down into those 66-bit blocks and do a really deep level of analysis. It also comes with a simplified viewer, which is a little easier for the user, which uses a color-coded scheme to indicate things like the types of blocks that have been seen, where errors are, and really allows you to just quickly go to where something interesting is happening in the stream rather than having to go bit by bit and focus through the different test scenarios. So very similar to the Bitfire for lower speeds, just at the 10 gig space and focused on the 66-bit block. So again, very excited to bring these tools out and make them available for use in your own lab. In addition to the two tools that we're focusing on in this presentation, I also wanted to mention that the UNH-IOL also offers other commercialized tools in the Ethernet space. We have a tool for auto negotiation for twisted pair PHYs, which looks at the timing analysis of that handshake that helps determine the optimal speed that a link will come up at. This is particularly useful for newer speeds such as 10 gig, as well as 2.5 and 5 gig N-base-T types, which are coming out right now. We also offer a tool to interface with your oscilloscopes, which allow for electrical testing of both 100-base-TX and 1G-base-T. Outside of the Ethernet space, we also commercialize tools for many of the other technologies in that basket of 30 technologies that we test here. For example, for Internet protocol, specifically IPv6, we have an intact software tool that allows you to get ready for either IPv6 Ready Logo program or the US government v6 program. We have a test tool in the NVMe flash memory space called Interact. In the 802.1 bridging and time-sensitive networks area, as well as in the audio-visual bridging space, we have a test tool called Violet, which helps do detailed analysis, triggering, and sending of frames for audio-visual bridging, pro audio, and automotive applications. And finally, we also have custom electrical test boards available for MIPI PHYs, specifically for DPHY, MPHY, and CPHY. So it's just a package of different tools that are available, all of which help reduce time to market in the different technology spaces. So in addition to the two new tools that we're making available now, I just wanted to quickly mention those other tools.
Thank you, Jeff. We're now going to begin answering the questions submitted during today's webinar. As a reminder, you can still submit questions through the questions box on your control panel. Our first question is from Greg. Is it possible to use the tool from scripting language or Python rather than GUI?
So the tool, right as it exists now and is being commercialized, is really built to handle just from the custom in GUI test generator. It's a very simple language. It also comes with a set of conformance test tools, which is that suite of tests which are already pre-packaged to do testing to the conformance test suites that we have written. So that automation piece already exists in there. If you're looking for the case-by-case or something outside, currently the tool doesn't support like a Python backend interface.
Thanks, Jeff. Our next question is also from Greg. Can the captures be exported to a CSV file?
Yeah, so as Kate mentioned, there's several different output types, and really, although this isn't designed to integrate into every custom test harness that's out there in people's different labs, it is built to output something that can be easily integrated into those systems. So CSV output is one potential output of the frame stream and/or any results that come out.
I'll now begin with some questions from students, staff, and the greater lab community. As a reminder, you can still submit your questions through the question box. Question here, what specific problems were you trying to solve when you developed the Bitfire and Bitfire 10G? Is there a common objective for all the tools you come up with?
Yeah, so the reason we build custom test tools is to give insight into particular testing areas, in the case of these Ethernet test tools, down to that single bit level that may not be available through a commercial test tool that you can buy off the shelf. So again, it's really a supplement or a complementary test tool to stuff that you would buy commercially that drives a little bit deeper and has a specific focus on particular layers of the technology. So we try to build test tools to fill the niche spots that aren't necessarily addressed by other commercial test tools.
Our next question is from Steve. Is licensing available for 10-base-T?
So the Bitfire non-10G version is enabled to support 10-base-T by default. And then depending on your membership, our licensing program will either add on top of that the fast Ethernet, gigabit Ethernet, or 10 gigabit Ethernet speeds, but by the base model, it will support 10 base T.
Our next question is also from the Greater Lab community. Which Ethernet trends are you most interested in supporting? Are there some that lie outside your interests or testing capabilities?
That's an interesting question. There are always things that lie outside of the current abilities or current interests. We're driven by our member company's interests. So if a member company comes to us and says, I'm really interested in testing this specific optical type or the specific layer, that's what drives us to do development in that space. So we really rely on our member companies to help focus where we're going to in the future. As far as things that are in development, just to briefly talk about that, we do have test tools in progress that are focused at the 25 gig serial speed for Ethernet. So things that would handle 25 and 50G applications. We're tracking development in the 400 gigabit Ethernet space. We're also working in the automotive space for both fast Ethernet and gigabit Ethernet over one pair, and we have test tools in that space as well that we're soon down the line should also be able to make commercially available.
Are you competing against some of the technology companies that support you, companies that may have stream generators of their own, or is this test tool unique?
This is definitely not in competition with those test tools and is not at all designed to replace them. Commercial packet generators can provide large streams, complicated flows of packets, often at higher protocol levels than what this test tool is designed to focus on. This test tools are really a supplement, or like we mentioned before, complementary to commercial test tools, and allow single bit level variations are specific for these low levels. So it's very complementary to what other people make available, and I think that answers that question.
Great, thanks, Jeff. Another question here from students and staff. What is the general state of 10G testing? Isn't it all fairly well standardized and established by now?
Yes, and that's one of the reasons that making this tool available for use in other companies' labs is really exciting right now. It is a bit more of a mature technology, and it really, by making it commercially available, helps reduce their dependence on us as a gating function, brings that a little closer to home, helps reduce time to market. So that's one of the reasons we're commercializing the product, actually, is because it's entering into that state.
We have another question here from Greg. Do you have estimated costs of the tools already known, and who should we contact?
So for contacting licensing and pricing, excuse me, it would be perfect to reach out to me directly. That's Jeff Lepak. I'm at the UNH-IOL. My email address is jrlapak@iol.unh.edu. That's also available in the presentation. And we do have the licensing models and pricing information, and be happy to give that to you outside of the webinar.
We have time for just a couple more questions in case your question doesn't get answered. Once again, we will address it offline. I have one question here. Have you submitted patents on Bitfire and Bitfire 10G technology?
We don't have any patents on this technology. These are, tools that are built to analyze single bit level. There's not anything necessarily patentable about that. There are other people that make packet generators and packet flow devices. So this is just, again, it's a complementary tool.
Thank you, Jeff. And thank you, Kay and Stephen as well. And thank you to everyone for attending today's webinar on our newly licensed Ethernet test tools. We appreciate your time. Again, the hashtag for the webinar are #Ethernet, #Ethernet testing, and #10gig. We will follow up with you after the webinar, and you can also contact me or Jeff with any additional questions. My email address is mbernazzani@iol.unh.edu. We'll also send you an email with a link to the recorded version of this webinar and presentation. On behalf of the UNH-IOL, thank you again for joining us today, and have a great rest of your day.